And these two and call them RL dash. So the current here IC. So V out is equal to minus IC times RL dash equal to minus alpha IE RL dash. So that's equation number one. As you can see, V out function of IE. We don't want that. We want IE to be function of VI, right? Now, what is IE, sorry. What is IE here? This point is also VI because it is from here to ground, from here to ground. So we can find IE as a function of VI. So we can say IE is equal to VI over RE plus RE. Look, RE is part of the transistor circuit, right? But RE is external one, huh? So this is added, as you can see here. And this will be your equation number two. Now, if we sub 2 in 1, we have V out is equal to minus alpha IE, which is VI, RE plus RE times RL dash, and the gain AV is V out over VI, which is minus alpha RL dash over RE plus RE. So that is your gain. Now, as you can see here, if we short out RE, then we'll have alpha over RE, which is GM. So we'll go back to the previous design. Now, for the output resistance, I will do it first. For R out, we do the same thing. We'll short this. When we short this, IE will be 0. If I is 0, this will be open circuit, and R out is the same as the previous one is RC. So you can see this configuration has nothing to do with the output resistance. The output resistance using with or without RE, it will be the same. Lakin, you can see here the gain changed now, right? We will divide by RE, which means the gain will decrease. And finally, we have to find the input resistance. So be careful here. Don't tell me the input resistance is RB in parallel with the combination RE plus RE. That is wrong. So if you say Rn is equal to RB in parallel with RE plus RE, that is completely wrong. You have to be careful because this is nothing parallel with this, right? The current here, right, is different than the current here, okay? And IE here, and this is IB here, right? So we cannot say they are in parallel because we have something here also. So what about this part? So if you parallel this, what about this? You have to include it in the analysis. Lakin, if this was not there, then we can simply say these two are in parallel, right? So since it is there, then you have to be careful and you must do the analysis here. So what we can see here is RB in parallel with, I'll call this RIB. So the input to the base, RIB. So we can say simply the input resistance, I'll do it here. Rn is equal to RB in parallel with RIB. RB is known to us. Lakin, what is RIB? RIB is the resistance in here, which is V at this point, which is VI, right? Or we call it VB, let's say, divided by IE. So RIB is equal to VB divided by IE. Sorry, VB divided by, divided by IB, right? Equal to VB divided by VB عبارة عن ايش؟ IE, right? This is IB. VB عبارة عن IE into RE plus RE. This is equal to RIB, is equal to. We want to relate these two. IE equal to beta plus 1 into IB divided by IB into RE plus RE. So you can see RIB cancelled IB, and we have RIB will be beta plus 1 into RE plus RE. Now this we have to use use it with invariant with RB, and we'll get the input resistance. And this we call it the reflected impedance. Because if we have something in the ammeter and we reflect it to the base, we have to multiply it by beta plus 1, which is the relation between IB and IA. If we have something in the base and we want to reflect it to the ammeter in series, good. We reflect here in parallel, but if we reflect down, we have to reflect in series. Then we'll say it is RB over beta plus 1. So if I reflect from the ammeter to the base, reflection rule. If I want to reflect from the ammeter to the base, we multiply by beta plus 1. If I want to reflect from the base to the ammeter, we have to divide by beta plus 1. So this basically the common ammeter amplifier 3 configuration where we have RE or we don't have RE. Now if we add the bypass capacitor, then it will short this. So in AC it is not there anymore, and we are coming back to the basic configuration. Now the second amplifier is the common base amplifier. Common base amplifier. So in common base, as we said, that the base is common to both the input and output. So in this one, we have the input will be applied from the ammeter, right? And we can take the output from here, that is RL. But we'll assume there is a biasing for this, so we can use a bias current here, IE, to bias this circuit, all right? And this is V out, this is VCC, and that is RC. So this is called the common base amplifier. So IE is used for biasing. Now if we know the current, let's say the current is 2 milliamps, right? 2 milliamps, IE, and we know beta of the transistor, let's say it is 99. Then from this bias current, we can find what is IC, because we know that IC is alpha IE, which is beta over beta plus 1 times 2 milli. So we can find what is IC. If we know IC, then we can find GM, we can find R by, and we can find RA. That is for the DC analysis. So in DC analysis, we'll make this open circuit. So we have only current IE in the circuit, which is we can relate it to IC. Now for small signal analysis, Rn is here. So this is the input resistance, which is after the source. R out is here, which is before the load. We have to be careful. But if we have Rs here, again, the input resistance should go from this after the source, because Rs is part of the source. You should not include it in the input resistance. Now again here, as you can see, the ammeter is not grounded. So as I said before, it is easier to use the T model. So this is the collector here, this is the base, and this is the ammeter. So if we sketch the T model, this is A, B, C, we can call this alpha E, this is RA. So that's the transistor. Now, the current source is DC will be open circuit, so it will not be included in the here, so it is open circuit, right? And from here we have the capacitor, it will act as short circuit, and we have the source VI to ground. The base is grounded, so we ground it. And from the source, we have RC from the collector, sorry. And because this will be, the capacitor already shorted out, and we have RL, and that is V out. So the input resistance is the resistance seen after the source, and the output resistance is the resistance seen before the load. And we know that this current is IA. So again, I'll do the same. Here I'll call this RL dash. Now the output